Doping the wafer. This step starts with the wafer that has an oxide mask, the dopant is applied, and then the mask is removed. As the doping is a high temperature annealing process, the step begins with an RCA clean of the wafer. Once the wafer has been cleaned, it is placed in a clean spinner that has only been used to apply dopant. This avoids contamination. The spinner ensures a thin, uniform layer of spin-on dopant is left on the wafer. The residual film can be seen as a color change on the wafer. The wafer is then transferred onto the hot plate for baking to drive the residual solvents off. A special process of heating the wafer gradually to higher and higher temperatures helps ensure the dopant adheres properly and reduces the chances of cracking or flaking of the dopant layer. First, the wafer is heated to 80 degrees Celsius for 5 minutes. Then the temperature is increased to 180 degrees and baked for another 5 minutes. Then the temperature is further increased to 250 degrees Celsius for 5 more minutes. The final bake is at 275 degrees for the final 5 minutes. At this point, the wafer is removed from the heat and allowed to cool. The wafer is now ready for the thermal process that will drive the dopant into the silicon. The spin-on dopant is now essentially a glass layer on the wafer and is considered an infinite source of dopant, in this case phosphorus. A thermal process is now used to drive the dopant into the wafer. Of course, the oxide mask created in the previous step protects much of the wafer from being doped, but openings in the mask allow the dopant to be driven into the silicon, and this process will create the source and drain areas of the MOSFET. The rapid thermal process, or RTP machine, uses a series of lamps to rapidly heat the wafer within a gas atmosphere to achieve the required doping of the wafer. The beginning of the process is annealing the wafer in a nitrogen atmosphere as the temperature rises. The red LED display on the bottom left corner of the screen shows the wafer temperature. The temperature can also be seen as it is graphed on the monitor. The thick purple line in the bottom of the monitor shows the nitrogen gas level. Once the wafer is at 900 degrees Celsius, the nitrogen flow is replaced by an oxygen flow. This oxygen creates a thin oxide layer under the spin-on dopant while driving in the dopant, which will help completely remove the residual dopant later in the HF etchant solution. The thin purple line near the top shows the wafer temperature. After a couple minutes of driving the dopant in at high temperatures, the RTP machine switches from oxygen back to nitrogen and gradually cools the wafer. The RTP process is then complete. Once the wafer is cooled to 50 degrees Celsius, it is carefully removed from the RTP machine. At this point, the source and drain terminals have been properly doped, and it is time to remove the spin-on dopant with hydrofluoric acid. Bringing the wafer to the wet bench, the spin-on dopant is removed from the wafer by dipping it into a 10% hydrofluoric acid solution for about 5 seconds. The wafer is then dipped in DI water to stop the etching process. At this point, the spin-on dopant has been removed from the wafer, but the mask is still in place. Some of the wafer is oxide mask and some is doped silicon. The wafer can be checked for successful doping by measuring the sheet resistance of the wafer. A drop in the resistance indicates the doping was successful. The next step is the removal of the oxide mask. However, the oxide mask layer etched into the wafer contains the mask alignment marks that are needed to align the gate oxide lithography pattern in the next step. If the mask oxide was to be removed at this point, the alignment marks would also be lost. To prevent the loss of the mask alignment marks, the wafer is placed in the spinner and the marks are carefully covered with a drop of photoresist, and then the bulk of the resist is spun off the wafer. The wafer is then baked to harden the resist to ensure it won't be removed in the buffered HF solution. With the mask marks protected, the wafer is dipped in buffered HF solution until the oxide mask is completely removed. The length of time is monitored to track the removal process. When the oxide mask is removed, the wafer is fully hydrophobic. The process can be carefully monitored to ensure the oxide is completely removed. The MOSFET is about half finished now with the doped source and drain regions. The next steps are the gate oxide formation and finally metal deposition to create the metal gate, source, and drain contacts.